Hello friends, welcome to our new lecture of signals and systems. Today we are going to learn about multiple transformation of continuous time signal. So, what happens that in our last lecture we have learned all this transformation individually like time shifting, time scaling, time reversal, amplitude scaling we are going to learn in our coming lectures. So what happens that in some complex operations it requires more than one kind of operations described here. So the combinations of operations takes place in a single signal. So suppose if xt is a signal, then xt can undergo multiple transformation by k minus at minus b, where xt is time shifted here by b units, it is scaled by a units, it is reversed by minus 1 here, as the signal minus represents that it is reversed, the signal is reversed, and then it is amplitude scale by k units. So here we can see that in the signal xt it has undergone all kinds of transformation listed here. So we are going to learn in this video how to perform or how to achieve multiple transformation in continuous time signal. So one thing we need to remember that whenever we do multiple transformation, we will follow a priority order. That is, first we will perform time shifting. That is, first we will perform time shifting. This x of t minus b first. Second, we will perform time scaling. That is, x of t will then become x of at minus b in second step. In third step, we will perform time reversal. That is, x of t will become finally x of minus at minus b in third step. And in fourth step, finally, we can perform amplitude scaling. That is x of t will finally become kx of minus at minus b. Fourth step. Like this, step by step, if we follow the transformation, we can achieve our final result without any error. So this will be more clear when we perform this with an example. So let's start. Let us consider xt is a triangular signal. Xt is our triangular signal defined between minus 1, 0 and 1. This is 1 unit and this is t, and we need to perform multiple transformation to achieve x of 3t plus 2. Okay, so as discussed above, we will first perform time shifting. Second step, we will perform time scaling. So here we can see that our signal is only having shifting. Our signal is only having shifting and scaling operations. No reversal and no amplitude scaling is present here. So this is a simple example. So our priority order will be only consisting of time shifting and time scaling. So let's see. In first step, we will perform our time shifting, which is x of t plus 2. Now we know that the general notation of time shifting is x of t minus t naught. So if we will express this signal in general expression, then it will be x of t minus minus 2. That is, we need to shift our signal by minus 2 units, right? So we will shift our signal minus 1 minus 2 in all the units. So 0 minus 2, and this will be 1 minus 2. If we extend this in the time domain, it will be minus 1 minus 2. That will somehow it will come here. This is minus 1 minus 3, then 0 minus 2, then it will be minus 2, then 1 minus 2, and it will become here directly minus 1. So our signal will be shifted here. This is our step number 1. This is our signal x of t plus 2. Now this is not our final answer. Next, in step 2, we have to perform the scaling of the signal, that is x of 3t plus 2. Now as we learned in our previous lectures, whenever there is a signal scaling of the signal by x of alpha t, then we simply divide the time axis by alpha, right? So here also we will just divide our signal by 3 units, and this also will divide by minus 2 by 3, and this will divide minus 1 by 3. So let's plot this signal nicely here. Let's erase it and make it more clear. So we have divided by signal as it is scaled by 3 units. So in the time axis, by applying the shortcut method, we just divided all the time axis by all the values of time axis by 3 units. So ultimately we will get our signal between minus 3 by 3 will be minus 1, between this is minus 1, then minus 3 but minus 2 by 3, this will be somewhere here, minus 2 by 3, and minus 1 by 3, this will be somewhere here. So our new signal will somehow look like this. So this is our final signal, which is represented as x of 3t plus 2.